So we are going to continue from where we stopped last week. So we finished the structure questions. So today we are going to discuss the essay questions. Okay, so section C essay question number 1 sounds like this. Describe with explanation the reaction of group 2 metals from magnesium to barium with oxygen and water if equations were appropriate. So you have to describe the reaction, okay, with certain explanation why is it like that. Okay, the reaction of the group 2 element from magnesium to barium specifically with oxygen and also with water. Okay, and then you have to write the equations appropriate in here. So there's only oxygen and water only, so try your best to write. Okay, so of course you are going to say about the reactivity when going down to the group 2. So the reactivity of the group 2 metals with oxygen and water increase down to the group 2. So either you say that because they are, if you want to add, maybe you want to add because they are stronger reducing agent when going down to the group as the E naught value become more negative. Okay. Okay, so these are the statements that maybe you want to add inside here. So a beryllium, magnesium, calcium, strontium bond with oxygen to form metal oxide, MO. So according to the equation, 2M plus O2 give to MO. Okay, whereas a barium bond with oxygen to form barium peroxide, according to the equation, Ba plus O2 give BaO2. So try your best to write it down. Okay, so maybe some of the students you miss the fact that you have to mention that how does the barium react with the oxygens in here. Okay, and there's one more special description maybe you want to add in here is the reaction when magnesium. Okay, so that is for barium. Okay, then beryllium does not react with water since it is coated. Actually, this one no marks. This one no mark because we don't need to talk about beryllium. Sorry for that. I accidentally added in. Okay. So magnesium react with steam to form magnesium oxide hydrogen gas. Okay, so this is the equation that you have to write. Okay, so specifically you must mention that magnesium react with steam in here. Okay, so this is the key points. Okay, and then calcium, strontium, barium react with water to form metal hydroxide. So M plus 2H2O give MOH2 plus H2. So this is how you should describe all the 10 points inside here for the reaction of the group 2 elements from magnesium to barium with oxygens. Okay. Okay, so that is for 1A. Then immediately we goes for 1B. When a 1.00 gram of sample of a group 2 hydroxide formula QOH2 dot X amount of water is heated, it dehydrated into anhydrous hydroxide QOH2, losing 0.542 gram of the form in the form of steam. So in the first process, you can see that the first water that is lost is due to the XH2O in here. Okay. Then on a subsequent constant mass, a further mass loss of 0.68 gram is recorded. So in here, this loss is due to another water is lost, but the water is due to the dissociation of the QOH2 in here. Okay, so later we have to write the equations for that. Okay, so identify the metals in here. So these are how we are going to solve. So first of all, you have to calculate you have to first deduce the reactions that happen in the first step. The first step is the dehydration for the NH2O. So initially you have 1 gram, then you form a 0.4, then the remaining is 0.542 gram of the losing. So the remaining mass belongs to the Q hydroxide. Okay, so therefore in here you can calculate the mole of the QOH2 is equals to the mole of the H2O, which is equals to 0.0378. Why can we say like that? Because stoichiometrically, 1 mole of the 1:1. Okay. So molar mass of the QOH here is 0.458 divided by 0.00378. You get 1:1 mole. Okay. So X is equals to 12 times 16 plus 1. So you get 87.2. Therefore, metal Q is barium in here. Okay. Okay, so that is how you are going to calculate for B. Yeah? Okay, so that is for question number 1. So immediately we go to question number 2. The decomposition temperature of beryllium carbonate and strontium carbonate are -138 and -1194 respectively. Compare and explain the relative thermal stability of beryllium carbonate and strontium carbonate. So how are you going to explain? So still remember the 8 keywords or not? So first you need to mention that beryllium carbonate decomposes easier compared to strontium carbonate. Okay, strontium carbonate is more thermally stable than beryllium carbonate. Then second point, of course, you have to write the equations. Okay, so where MCO3 give MO plus CO2, so you substitute to any of the strontium or beryllium also can. Okay, then because you uses beryllium, so you take advantage of the beryllium as a small ion to start to explain. So the initial factors that influence all this is due to beryllium ion has a smaller radius than the strontium ions. Okay, sorry for the mistake here. Yeah, it's supposed to be BE. So here. Okay, so these are the key points that you have to write down. Then you have to write that size of the barium ion is smaller than of the strontium ion. So barium ion has a higher charge density compared to the strontium ion. Okay, so since it has a smaller size and high charge, therefore it has a high charge density. So high charge density will lead to high polarizing power. So what does high polarizing power cause? So high polarizing power of the barium ion causes the distortion of the electron cloud of the carbonate ion by the small beryllium ion. So what will happen when the small carbonate ion is distorted by the beryllium ion? So this will weakening the CO bond inside the carbonate ion. Okay, so making the BO to be easier to form. Furthermore, barium oxide is more stable than the strontium oxide, so making the decomposition become more easier. So these are all the 8 points that you guys will try your best to explain whenever you are trying to explain for the decomposition of no matter carbonate, nitrate, or hydroxide. So the point of explaining them are all the same. Okay, so that is for 2A. Then 2B, solubility of the sulfate compound of the group 2 element in the periodic table are shown below. So these are the solubility in 100 grams of water. State and explain the factor that influence the variation of the solubility of the group 2 sulfate compounds. So in here, of course, you have to mention that the solubility of the group 2 sulfate decrease when going down to the group. So you have to make use of the equation, enthalpy change of solution is equals to hydration minus the T's energy. So the more negative the enthalpy change of solution, the more soluble the salt. Or you can also write that in here, I would personally more recommend if you write that enthalpy change of the solution is negative since the enthalpy change of the hydration is greater than the lattice energy. Okay, making the salt more soluble. Okay, so this is something that you might want to add, and then only then you start to say that the size of the group 2 ion increase when going down to the group. However, so both hydration and lattice energy decrease down to the group 2 sulfate. However, the decrease of the hydration is more significant than the lattice energy due to the large size of the sulfate ions in here. Okay, so that is why the enthalpy change of the solution is more and more exothermic. Okay, okay, so that is how you are going to explain the solubility of the group 2 sulfate by making use of all the points that I already mentioned again and again during our lessons. So try your best to remember them as much as you can in here. Okay, okay, so that is all for question number 2. So immediately we go to question number 3. Explain the variation of the properties of the when going down to the when descending group 2. This one, what write appropriate equations. Number 1, first ionization energy of group 2 elements from barium to barium. So you have to mention that first ionization energy decrease when going down to group 2. So why? And if possible, in this case, like I said, when it comes to essay question, you have to try your best to describe as complete as you can. So then you might want to define what is first ionization energy, and then you might want to write the equation. Like I said, don't care where are the marks located. You just try your best to write everything to the fullest in here. Okay, so also define what is ionization energy, the energy absorbed to ionize 1 mole of the gaseous atom to form a unipositively charged ion under standard condition, and then you write your chemical equations in there. Okay. Okay, so why does the ionization energy decrease when going down to the group? This is due to the atomic radius increase when going down to the group as the screening effect increase with the number of shell. As a result, effective nuclear charge decrease. Okay, so that is how you are going to explain the first ionization energy for group 2. And then as for the melting point, so you have to mention that they are all group 2 metals are alkali of metal. Okay, so then generally, all of them are whole by metallic bond. Okay, that is the second point that you want to highlight. Only then you highlight, okay, saying that the melting point decrease. So group 2 are whole by metallic bonds. So metallic bond strength decrease as the metallic radius increase. Okay, so that is how you are going to explain in terms of the melting point. So why is it that when going down to the group, the boiling point, melting point decrease in here? Okay, so that is the 3A and B. Then C, reactivity of group 2 element with oxygen to form its respective oxide, following by dissolved oxide with water. So what happened to the reactivity? So you are going to say the reactivity of group 2 metal with oxygen increase down group 2. So as the electron potential or the inert value of the metal become more negative, or you can say that they are stronger reducing agent. So this one is the same point that I mentioned just now in question number 1. So try your best to describe as fully as you can there. Then you have to mention beryllium, magnesium, calcium, strontium bond with oxygen to form metal oxide. So you form 2M plus O2 give 2MO, whereas beryllium does not dissolve in water. Then, one more is the barium. While barium form barium hydroxide. Okay, according to the equation. So just write down. Don't care where are the marks located. Just do to your best to write down as fully as you can in here. Okay. So magnesium oxide does not dissolve in water, whereas magnesium and calcium oxide dissolves very readily in water. So barium burn with oxygen to form BaO2. So barium oxide when dissolved in water, this one I didn't write dissolve in water. Sorry. Dissolve in water. So barium hydroxide dissolved in water to form barium hydroxide and also hydrogen peroxide according to the equations in here. Okay, so you have to describe as complete as you can all the reactions in here. Maybe you want to reason why is it that the barium oxide does not dissolve in water since it is an ionic compound with high covalent character. So you might want to explain all that. Okay, so that is what happens towards this one. And then strontium form this dissolve in water to form a strontium hydroxide. So these are all the key points that you might want to try your best to write as complete as you can whenever you are answering all these essay questions in here. Okay, so that is for question number 3. Okay, then we go to question number 4. Okay, barium shows a diagonal relationship with aluminium in the group 13. Anhydrous barium chloride and aluminium chloride has polymeric structure in solid state. When heated, they sublime to the dimer in vapor state, and when further heated strongly, they form monomer of barium chloride and aluminium chloride. Now, 1. Draw the Lewis structure of the monomer and dimer for both barium chloride and aluminium chloride. So you have to draw the monomer and the dimer of the aluminium chloride. So if you are able to describe this correctly, then you should be able to get the first mark. In here, they want the Lewis structure. So the lone pair, bond pair, electron, all of them, try your best to draw as complete as you can. Okay, so that is for number 4A1. Then 4A2, both barium chloride and aluminium chloride are soluble in water to form aqueous solution which are acidic. Using Sulfate education, why both of them are acidic. So first of all, you have to mention when dissolved inside water, they hydrated to become the complexes. So what happened during the formation of the complexes? So they undergo hydrolysis. Okay, then react, write the equation, then explain why are they acidic. Okay, so you have to first mention barium chloride, aluminium chloride, both dissolved in water to form hydrated salt of Be or H2O4 2 plus and AlH2O6 3 plus. So both of them has a small ionic radius and high charge or high charge density. Okay, so when dissolved inside water, okay, so they undergo hydrolysis in water to form acidic solution. So this is the equation BH2O4 2 plus H2O give BOH H2O3 plus, not minus. Sorry for that. And then for aluminium, it also undergoes the same hydrolysis in here, but here is 2 plus, 2 plus in here. Okay, so these are the respective equations of how you have to explain why does they undergo hydrolysis in here. Okay, so try your best to describe and explain as fully as you can with regards to why is it that the barium chloride is acidic in here. Okay, and last but not least, is the reactions with the oxygen. So both barium and aluminium oxide are amphoteric oxide. Using suitable equation, explain why barium and aluminium oxide are amphoteric. So barium oxide and aluminium oxide are amphoteric because they are ionic compound with high covalent character due to the high charge and small ionic radius of barium. Then this is the second point that you have to write. Only then you write equations. BO plus 2HCl give BCl2 plus H2O, or you write in ionic equation also can. It doesn't matter because the question does not specifically say that you react with which compound or you react in the form of ions. So you can use either a chemical equation or ionic equations. Both are accepted. Okay, so then the reaction with the base in here. Okay. Okay, so with that, that is for how you're going to solve for essay question number 4. Teacher, is the state of matter important or not? In this case, not important. So you don't have to write the state of matter, also never mind. Okay, so the most important in here part in here is you are able to understand on how to explain and describe the amphoteric properties of the barium oxides in here. Okay, okay, so that is for question number 4. So immediately we go to question number 5. Boiling point of the barium chloride and magnesium chloride are 483 and 1412 respectively. By using Lewis structure, explain the difference in boiling point. So why are they different? So this is the Lewis structure of barium chloride and magnesium chloride. So they already asked you to draw the Lewis structure, so you must draw. Then you have to mention that barium chloride is a simple covalent molecule held by weak van der Waals forces. So therefore, has a lower melting point, whereas magnesium chloride are ionic compound. They are held by strong electrostatic attraction forces of attraction. If you want to add to form a giant ionic crystallities. This require material. Okay, so up to you on how much you want to write in here. Okay, okay, so that is for number 5A. Okay. Okay, immediately it goes to 5B. Due to the diagonal relationship between beryllium and aluminium, beryllium resembles aluminium regardless of physical or chemical properties. Using beryllium oxide and manganese oxide as example, compare and contrast the physical and chemical properties of the two oxides here. So of course you have to mention that beryllium oxide has a higher melting point than magnesium oxide. Okay? No, terbalik. Lower. Supposed to be lower. Oh, the higher, yeah, correct, higher. Cannot be used. Okay, sorry. Barium oxide has a higher melting point than magnesium oxide as the ionic radius of the barium is much smaller than that of aluminium, as therefore the lattice energy of barium oxide is so much greater than the magnesium oxide. Okay, so that is why it has a higher melting point. Okay. Furthermore, barium oxide is amphoteric, so when dissolved, while magnesium oxide is basic, so when react with the acid, so you form BeCl2 or MgCl2 in water. So writing either one equation, the marks is there. Whereas barium oxide can further react with the sodium hydroxide to form sodium berylate. So explain why barium oxide is amphoteric. Okay, so because it is an ionic compound with high covalent characteristic, due to the high charge small ionic radius of the barium that cause it to have a high covalent characteristic. So explain to the fullest as you can about the chemical properties in here. And last but not least, try your best to mention barium oxide is insoluble in water, whereas magnesium oxide is sparingly soluble in water. Okay, so that will be more or less of the points that you can try your best to describe as fully as you can for the comparison between barium oxide and magnesium oxide. Okay. Okay, so with that, that is for question number 5. Last but not least, we have question number 6. Beryllium, calcium, and barium are metals from group 2. Compare and explain the melting point of beryllium, calcium, and barium. So you're going to mention that their melting point increase from barium to calcium to barium, or you said decrease from beryllium to calcium to barium. Okay, either way. Okay. Okay, so as the metallic radius increase from barium, decrease. So therefore the metallic bond increase. Okay. Okay, so these are always the key points inside here. And then try your best to mention also all of them are ion. Beryllium, strong calcium and barium are hold by strong metallic bond. So try your best to describe this one too. Okay, like I said, don't care where are the marks located. You just, as a student, you just try your best to write as complete as you can. Okay, B, when dissolved in water, barium and calcium and barium react differently under different conditions. Using suitable equation, describe the observation of the reaction of this metal with water. So first of all, you have to mention that barium does not dissolve in water due to the presence of the oxide layer. Okay. And then calcium dissolves slowly in water to form a cloudy solution of the calcium hydroxide. So in here, because the questions wants you to write the observation, okay, so you must say that it is a cloudy solution, okay, or white precipitate is formed around the solution also can, okay, either way. Okay, and according to this equation, calcium plus water give calcium hydroxide plus hydrogen, and then barium dissolve completely in cold water to form a clear solution. So the equation is the same as in the calcium hydroxide. So if you write again the equation, so usually they will classify as one equation from the calcium and the barium. Okay, so because they are the same in here. Okay. Okay, so that is how we are going to answer 6A and 6B. Finally, we go to 6C. Explain the acid-base properties and the solubility of barium hydroxide, calcium hydroxide, and barium hydroxide. So you must first mention that barium hydroxide is amphoteric. Generally, you have to mention that basicity increase from barium hydroxide to calcium hydroxide to barium hydroxide. So this is the first keyword. So barium hydroxide is amphoteric due to the barium has a high charge of small ionic compound with high covalent character. Also try your best to explain. Okay, so try your best to describe. Okay, then you have to write the acid-base property and the solubility. Okay, so you write what happened when barium hydroxide dissolved in the acids and what happened dissolved in base. Okay, okay, so these are the case for the beryllium, and then as for the calcium, so calcium hydroxide and barium hydroxide are basic. So you have to mention that calcium hydroxide dissociate partially in water, while barium hydroxide dissociate completely in water to give different acid-base strength in here. Okay. Okay, so I guess with that, that is all for the discussion of the essay questions that I would like to share with you for this chapter. So hopefully you'll be able to understand better on how to answer the chapter 2 questions. So chapter 4 questions. So I guess that is all for our classes today. So see you all on our next lesson. Okay?